Welcome to RK Tutorials. Solutions to Engineering Mechanics Textbook 5th edition by S. Timoshenko, D.H. Young, J.V. Rao and Sukumar Patil. Problem set 2.1 and question number 2.1. A man weight W is equal to 712 newtons holds one end of a rope that passes over a pulley vertically above his head and to the other end of which is attached a weight Q is equal to 534 newtons. Find the force with which the man's feet press against the floor. This is the given problem. That means there is a man whose weight is 712 newtons is holding one end of the rope. Clearly you can see in the picture. One end of the rope. That rope passes over the pulley. At the other end of the rope, a weight Q is attached. The weight of the Q is given as 534 newtons. Our aim is to find the force here with which the man's feet press against the floor. Here, given that weight of the man is 712 newtons and weight of the Q is 534 newtons. To analyze this system, let us analyze and let us draw the free body diagram of all the three parts that are available here. The three parts are weight Q, the rope that passes over the pulley, and the man who is holding the rope here. Let us consider the weight of the Q. If you draw the free body diagram of the Q, here you can see the weight is acting downwards here 534 newtons. At the other end, the rope is attached. By considering the equilibrium of the weight Q, the force in the rope must be upwards and the magnitude of the force is 534 newtons. Since weight is acting downwards, the force in the rope must be upwards and the magnitude is 534 newtons. The same rope is passing over the pulley. So if you draw the free body diagram for the pulley, this side the force in the rope must be downwards. To satisfy the equilibrium of the rope, this side the force must be downwards and the magnitude is 534 newtons. Since towards right side the force is downwards, once again by considering the equilibrium of the rope, the force in the other side of the rope must be downwards and the magnitude is also equals to 534 newtons. Now the same rope is holding by the man. That means the force acting in the rope which is holded by the man must be upwards by considering the equilibrium of the rope, and magnitude is 534 newtons. If you draw the free body diagram of this man, we know that weight is 712 newtons, and from this free body diagram we understood that the force acting in the rope which is holded by the man is upwards and the magnitude is 534 newtons. That's what we analyzed from this diagram. And there is a force acting on the man's feet by the floor. Now if you consider the free body diagram of this man, there are three vertical forces. All these vertical forces are inline. That means this 534 newtons also acting here vertically above his head, given that vertically above his head. That means all these three forces are in a same line. Hence, I can apply my equilibrium equation sigma Fy is equal to 0. By applying that sigma Fy is equal to 0, we can write the equation that F plus 534, both the forces acting in the upward direction, is equal to the force acting in the downward direction, that is 712 newtons. By simplifying this equation, I will get F is equal to 178 newtons. Hence, the force with which the man's feet press against the floor is 178 newtons. This is the answer. The solution for problem set 2.1, problem number 2.2. A boat is moved uniformly along a canal by two horses pulling with forces P is equal to 890 newtons and Q is equal to 1068 newtons acting under an angle alpha is equal to 60 degrees. Determine the magnitude of the resultant pull on the boat and the angles beta and gamma as shown in the figure. That means one horse is pulling in this direction with a force P, another horse is pulling in this direction with a force Q. The angle between these two forces is alpha. Now our aim is to find with what force the boat will move, that is the resultant force, and angle between the resultant force and the force P, that is beta, and the angle between R and Q, that is gamma. These values we need to calculate. Now this is our problem. In this, the given data P is equal to 819 newtons, Q is equal to 1068 newtons, and alpha is equal to 60. These three values are given. As you know, the resultant force equation R is equal to square root under P square plus Q square plus 2PQ cos alpha. Substitute those values. Since P, Q and alpha values are known, just substitute those values into this formula. Then you will get R is equal to square root under 890 square plus 1068 square plus 2 into 890 into 1068 into cos 60. Upon simplifying this, I will get the resultant force as 1698 newtons. Similarly, we know the formula that the angle between the resultant force and the one of the force P is given by sine beta is equal to Q by R into sine alpha. In this equation also, Q value is given, R value just now we calculated, and alpha value is given. So upon substituting those values, I will get sine beta is equal to 1068 by 1698 into sine 60. After solving this, I will get sine beta is equal to 0.5447. Then beta is equal to sine inverse of 0.5447, which gives the value of beta is equal to 33 degrees. That means the angle between the resultant force and one of the force P beta is equal to 33 degrees. Similarly, we know the other formula that the angle between R and Q is let gamma, and that gamma is given by sine gamma is equal to P by R into sine alpha. P value is given, R value we calculated, alpha value is also given. Upon substituting those values, sine gamma is equal to 890 by 1698 into sine 60. Then I will get sine gamma is equal to 0.454 and gamma is equal to sine inverse of 0.454. Then gamma is equal to 27 degrees. That means the angle between the resultant force and the force Q is given is value is 27 degrees. Okay. Hence all answers are R is equal to 1698 newtons, beta is equal to 33 degrees and gamma is equal to 27 degrees. Problem number 2.3. What force Q combined with a vertical pull P is equal to 27 newtons will give a horizontal resultant force R is equal to 36 newtons. That means there is a canal and boat is moving in this canal. This boat is pulled by 2 horses. Given that one horse is pulling with a force of 27 newtons and pulling in vertical direction. We also know that the boat is moving in horizontal direction. That means the resultant force is 36 newtons and it is horizontal. Now our aim is with what force the other horse is pulling this boat and what is the angle between R and Q that we need to identify. Since we know that this force is pulling vertical direction and the boat is moving horizontal direction, the angle between these two is 90 degrees. Let that angle is beta. Hence beta is equal to 90 degrees. Let the angle between R and Q is gamma. Now here the aim is to find the value of Q and gamma. Now in this problem, the given data is P is equal to 27 newtons, R is equal to 36 newtons and beta is equal to 90 degrees. Now the equation, we know that resultant force R is equal to square root under P square plus Q square plus 2PQ cos alpha. R value is given, P value is given, so I can substitute those values into this equation. Then it becomes 36 is equal to square root under 27 square plus Q square plus 2 into 27 into Q into cos alpha. The next simplification, squaring on both sides, I will get 1296 is equal to 729 plus Q square plus 54Q cos alpha. Or this equation can be rewritten as Q square plus 54Q cos alpha is equal to 567. 1296 minus 729 which gives 567. This is equation number 1. We also know the angle between P and R is 90. Let us use that value now. Now according to the equation, the angle between R and P is beta and it is given by sine beta is equal to Q by R into sine alpha. Let us substitute the known values, then it becomes sine 90 is equal to Q value is unknown, so it becomes Q only. R value is given, that is known, 36 into alpha, once again it is unknown, so it is sine alpha. So sine 90 is equal to q by 36 into sine alpha. This equation can be rewritten as sine 90 is equal to 1. So we can write q sine alpha is equal to 36, or sine alpha is equal to 36 by q. This is another equation, second equation. By solving these two equations 1 and 2, so these two equations and we have two unknowns. What are the unknowns? Q and alpha. And we have two equations and two unknowns, and we can solve for q and alpha. Let us see how we can solve this problem. So sine alpha is equal to 36 by q. This is from equation number 2. The sine alpha you can convert it into cos alpha, like as we know the equation cos alpha is equal to square root under 1 minus sine square alpha. Okay, so cos alpha is equal to square root of 1 minus 36 by q whole square, because sine alpha is equal to 36 by q. Next simplification, cos alpha is equal to square. By taking LCM, it becomes root under q square minus 1296 by q, or q cos alpha is equal to square root of q square minus 1296. Let us go back to our equation 1. What that equation 1 says? The equation 1 is q square plus 54q into cos alpha is equal to 567. Now let us take that equation q square plus 54q into cos alpha is equal to 567. We know that q cos alpha is equal to square root under q square minus 1296. You can substitute this equation straight away here. So it becomes q square plus 54 into square root under q square minus 1296 is equal to 567. Then 54 into q square minus 1296 is equal to 567 minus q square. Send this q square towards right side. Then it becomes 567 minus q square. Then squaring both sides so that I can avoid this root. By squaring on both sides, you will get 54 square means 2916 into q square minus 1296 is equal to 567 minus q square whole square. This is a minus b whole square formula. So it becomes a square means 321489 plus q to the power of 4 minus 1134 q square. So this equation you can further simplify, and then you will get q to the power of 4 minus 4050 q square plus 4100625 is equal to 0. So this is a quadratic equation in terms of q square. This is a quadratic equation in terms of q square. So you can solve this equation straight away by using the equation. Okay. So q square is equal to, so for any quadratic equation, you know the solution is equal to minus b plus or minus square root of b square minus 4ac by 2a. According to that equation, so b becomes here minus 4050 and a becomes 1 and c becomes 4100625. By substituting into this equation, so you will get q square is equal to 4050 plus or minus square root of 4050 square minus 16402500 whole divided by 2. So this you can solve. Then you will get q square is equal to 2025. Upon solving this equation, you will get q square is equal to 2025. So this total term becomes 0. Now, since q square is equal to 2025, q value becomes square root of 2025, which gives 45 newtons. Hence, the required force q value is equal to 45 newtons. Similarly, we also required to find the value of gamma. To find the value of gamma, let us go back to our equation 1. What is that equation 1? Q square plus 54Q into cos alpha is equal to 567. I can substitute Q now into this equation. Then it becomes 45 square plus 54 into 45 into cos alpha is equal to 567. The only unknown is alpha now. So cos alpha is equal to minus 0.6. You can simplify this and you will get cos alpha is equal to minus 0.6. Accordingly, alpha value is equal to 126.87 degrees. Once you know the value of alpha, you can calculate gamma by using either formula, or you can also calculate by using a simple equation alpha is equal to beta plus gamma. Beta value is known as 90 degrees and alpha value is 126.87. So you can calculate this one as 126.87 is equal to 90 plus gamma, or gamma is equal to 36.87 degrees, approximately 37 degrees. Or you can also use the equation sine gamma is equal to P by R into sine alpha. So P value is given 27, R value is also given 36, and alpha value just now we calculated as 126.87. Upon substituting those values, I will get sine gamma is equal to 0.6 or gamma is equal to 36.87 degrees. Hence, all the final answers you can say the Q value is equal to 45 newtons and gamma value is equal to 36.87 degrees. Problem number 2.4. To move a boat uniformly along canal at a given speed requires a resultant force R is equal to 1718 newtons. This is accomplished by two horses pulling with forces P and Q on ropes as shown in the figure. If the angles that the two ropes make with the axis of the canal are beta is equal to 35 degrees, gamma is equal to 25 degrees, what are the corresponding tensions in the ropes? That means in this canal, this boat is to be moved horizontally with a force of 1718 newtons. To achieve this, there are two horses that are pulling this canal in the direction of P and in the direction of Q. It is also given that the angle between the force P and the resultant force R is beta, and that beta is equal to 35 degrees. The angle between force Q and the resultant force R is gamma, and that gamma is equal to 25 degrees. Now our aim is to find with what force these horses are pulling the cart. What is the value of P and what is the value of Q? Let us go to the solution. The given data is R is equal to 1718 newtons, beta is equal to 35 degrees and gamma is equal to 25 degrees. From this given diagram, we can clearly observe that the angle between the forces P and Q is alpha, and that alpha is equal to beta plus gamma. From the given diagram, it is observed that alpha is equal to beta plus gamma. So I can calculate that alpha is equal to 35 plus 25, which is equal to 60 degrees. We also know that the beta is equal to 35 degrees, given that beta is equal to 35 degrees. Now, the formula for this beta is sine beta is equal to Q by R into sine alpha. Now, in this formula, we know the value of beta and also we know the value of alpha and R. We can substitute straight away. After substituting, I will get an equation like this. Sine 35 is equal to Q by 1780 into sine 60. You can rearrange this equation so that I can calculate Q value. That Q is equal to sine 35 by sine 60 into 1780. By solving this, I will get Q is equal to 1179 newtons. Similarly, we know the angle between resultant force R and Q is gamma. For that gamma, we know the formula sine gamma is equal to P by R into sine alpha. In this equation also, gamma value is known, R value is known, alpha value is known. We can substitute those values here. Sine 25 is equal to P by 1780 into sine 60. You can rearrange this equation so that I can calculate the value P. P is equal to sine 25 by sine 60 into 1780. Upon calculating this, I will get the required force value P is equal to 868.69 newtons. These two are the answers for this problem. Problem number 2.5. If in figure the horses pull with the forces P is equal to 1068 newtons and Q is equal to 890 newtons, what must be the angles beta and gamma to give the resultant R is equal to 1718 newtons? That means this is a canal. In this canal, this boat is to be moved in the horizontal direction along this R with a force of 1780 newtons. This can be accomplished by providing two horses pulling in these two directions along with P and Q. Now, one horse is pulling along this P with a magnitude of 1068 newtons. Another horse is pulling along Q with a magnitude of 890 newtons. Now, our aim is to find with what angle these two horses must pull so that the resultant force is horizontal. Let us go to the solution. The given data is P is equal to 1068 newtons, Q is equal to 890 newtons, and R is equal to 1780 newtons. As we discussed, our aim is to find the value of beta and gamma. We know that the resultant force formula R is equal to square root under P square plus Q square plus 2PQ cos alpha. In this equation, R value, P value and Q value is given. The alpha value is unknown. So there is only one unknown that you can identify from this equation. Let us substitute the values into this equation. 1780 is equal to square root under 1068 square plus 890 square plus 2 into 1068 into 890 into cos alpha. Squaring on both sides and solving this equation, then I can calculate that cos alpha is equal to 0.65. Hence I can calculate the alpha value, that is cos inverse of 0.65, which gives 49.46 degrees. Once you know the value of alpha, I can calculate beta and gamma. How? We know that let the angle between P and R is beta, and that beta is given by the equation sine beta is equal to Q by R into sine alpha. In this equation, Q value and R values are given, alpha value we calculated. Upon substituting those values, sin beta is equal to 890 by 1780 into sine 49.46. So this you can simplify, and then you will get sin beta is equal to 0.379, and hence you can calculate that beta value, which is 22.33 degrees. Similarly, let the angle between Q and R is gamma, and that gamma is given by the equation sin gamma is equal to P by R into sin alpha. In this equation, P and R values are given and alpha value we calculated. So by substituting those values into this equation, I will get sin gamma is equal to 1068 by 1780 into sine 49.46. After simplification of this equation, I can calculate that sin gamma is equal to 0.456, and hence gamma is equal to sine inverse of 0.456, which gives the value of 27.13 degrees. Now these two are the final answers for this problem. And problem number 2.6. Draw the free body diagram of the boom BC and point B as shown in the figure. Now this is the given figure. In that there is a boom BC. One end is fixed to a fixed support EF, and at the other end B, a string is connected. A, B, D is a string. At the end of the D, a weight Q is attached. Now, our interest is to find or draw the free body diagram of BC and at point B. The formulas or concepts required to solve the problem is: if any system contains the string or cable or ropes, etc., the force is along the axis and it is away from the support. Similarly, if the system contains any bars or struts or booms, the force is along the axis, and the direction will be decided whether it is a tension or compression is based on its equilibrium condition. Similarly, if any body is supported with wall or floor or trough, etc., there is a reaction force developed on the body, and that reaction force is always perpendicular to the support and it is towards the body. Okay, so with this concept, let us go to the solution of our problem. We are interested to draw the free body diagram of BC and also the free body diagram at B. Now let us discuss one by one. Let us consider the string AB. The force in the string AB is along AB and it is away from the support. That means if you look at that point B, B is the support and the force is away from point B, and this magnitude is S1. Let. Similarly, if you look at the same string AB from point A, then the force is along the string AB and it is away from A, that is S1. Okay. Similarly, you consider this BC. Now at the end of this BC, a we are applying a force in the downward direction. That means the boom BC is in compression. If boom BC is in compression, let that force is S2. Next, let us consider the string BD. Since it is a string, the force is along BD, and if you look at from point B, it is away from point B, or if you look at from point D, it is away from point D. What is the magnitude of that? Let us discuss like this. Just consider the weight D and the string here. Since weight is acting in the downward direction, the force in the string must be upwards and the magnitude is Q and from point D. To satisfy the equilibrium condition, if the force is acting in the upward direction from point D, it must be downwards from point B. Hence, this is the direction of the force in the string BD, and which is away from point B, and the magnitude is Q. Now, let us discuss this BC now. Since the force is acting in the downward direction at point B, we can easily observe that the boom BC is in compression. That means like this. If you look at that same force from point B, then this force direction will be opposite to the already force acting on BC. That means as far as BC is concerned, at B the force is acting in the downward direction, but from point B the same force will act in the upward direction to satisfy the equilibrium condition. So this is the free body diagram of BC. Now let us consider the various forces that are acting at point B. I am considering my XY axis. This is my point B. What are the various forces? The first force is Q, acts along BD and it is downwards. So this is force acts along BD and downward direction, and the magnitude is Q. The next one is the force in the string AB. It is along AB and it is away from point B, and the magnitude is S1. So away from point B, along AB, and the magnitude is S1. And the third force is along BC, but it is towards B, and magnitude is S2. Okay. So this S2 is opposite to the force acting on BC. Hence, this is the free body diagram of BC, and this is the various forces acting at B. We would also present the angles made by these S1, S2 and Q with the XY axis. For that, I will consider triangle ACB. In this triangle, just consider the triangle ACB. In this triangle, this angle is given as, angle A is given as 115 degrees, angle B is given as 35 degrees. Hence, what is this angle? This angle is 180 minus of 115 plus 35. Okay, so this becomes 30 degrees. That means this angle is 30 degrees. The angle made by BC with the vertical is given as 35. Similarly, the angle made by the BC with the same vertical must also be equals to 35, because the opposite angles must be same. That means angle between S2 and Q is equals to 35 degrees. This is the free body diagram of B. And problem number 2.7. Draw the free body diagram of the bars AC and BC shown in the figure. Our interest is to find only the free body diagrams of AC and BC. Now, in this problem, AC and BC are connected at C, and a horizontal force of 4450 newtons acting at C. It is fixed, at A it is fixed, and at B also it is fixed. Some various dimensions are given. Now, since at C a force of 4450 newtons are acting towards the horizontal direction, we can observe that the string AC is in tension and the bar CB is in compression. Since it is pulling in this direction, the bar AC will get elongated, the bar CB may get compressed. Hence, the force that acting at AC is in tensile, let the magnitude is S1, and the force acting at CB is compressive and that magnitude is S2. S2 clearly we can see it is compression. S1 clearly we can see it is tensile. So these two are the free body diagrams of AC and CB. We would also like to extend this problem by drawing the free body diagram at C. I would like to draw the free body diagram at C. What are the various forces acting at C? You can see here at C the force is 4450, one force is acting. Another force is the force in the string AC, in the bar AC, and another force is the force in the bar CB. But here the magnitudes and the directions are also important. First, let us calculate the angles made by the bars AC and CB. Let the angle made by bar AC with the horizontal is alpha and the angle made by CB with the horizontal is beta. Now from the right angle triangle AC, let us put a name here D. So from the triangle ACD, this angle is 90 degrees. So from the right angle triangle ACD, so tan alpha is equal to 762 by 915, which is 0.832, or alpha is equal to 39.79. Similarly, from the right angle triangle CBD, right angle triangle CBD, tan beta is equal to 762 by 610, opposite side by adjacent side, which is 1.249, and beta value is equal to 51.32 degrees. Let us draw the various forces acting at C. So this is my C and I am drawing my X and Y axis. Now tell me what are the various forces. Of course, the first force is 4450 acts towards right side. This is the first force, 4450 acts towards right side. The next one is the force in the AC. As far as AC is concerned, the force is tensile and it is away from C, magnitude is S1. But the same force, if you look at from point C, it is away from C and the magnitude is S1. Similarly, if you look at that bar CB, the force is towards C and the force is towards C and the magnitude is S2. Okay, it is exactly opposite direction. So if this is upwards, from point C the force is like this, and from point C the force is like this. Okay, so this value is S2, and the angle made by the horizontal with S1, of course this angle is alpha, we calculated that value is 39.79, and angle made by S2 with the horizontal is 51.32 degrees. Problem number 2.8. A smooth circular cylinder of weight P is lying in a rectangular groove is shown in the figure. Now in the given problem, there is a cylinder of weight P. P is acting here. It is supported by a groove DCE. So it is supported at G, clearly we can see, and the cylinder is supported at H. Now our interest is to find the free body diagram of the cylinder. That means we need to find what are the various forces acting on the cylinder. Of course, the first force is P, that is the self weight acting from point O, it is already indicated. Now since the cylinder is supported at point G, at G this support will introduce a reaction force which is perpendicular to DC and towards the cylinder like this. This is the reaction at G. Similarly, the cylinder is supported at H. Hence, this fixed support will introduce a reaction at H perpendicular to CE, and it is towards the cylinder, that is RH. So if you extend this RG, it must coincide with the force at O, and if you extend this RH, it must intersect at point O, because this is a concurrent system. That means the cylinder is subjected to three different types of forces. One is P, acts vertically downwards. Another one is RG, perpendicular to DC. And the third one is RH, perpendicular to C. Let us draw this onto a separate XY axis. Let us consider this is my X axis and this is my Y axis, and this is the center O. Now what are the various forces? Let us transfer all these forces onto this XY plane. The first force is the self weight P. Now here the P is here and the magnitude is P. Next, transfer this RG onto this XY plane. What is the magnitude of this force? RG. Similarly, third force is RH. Transfer this RH onto X. Just draw a line parallel to this onto that XY plane. What is the magnitude of this force? RC. Sorry, it is RH. RH. We would also like to represent the angles made by all these three forces. Of course, P is vertical, and we should represent angle made by RG and RH with either X and Y axis. Now, what is RG? RG is a reaction force which is perpendicular to DC. Given that DC makes an angle 45 degrees with the horizontal, DC makes an angle 45 degrees with the horizontal. Hence, its perpendicular, that is RG, makes the same angle 45 degrees with the vertical. Hence this angle becomes 45 degrees. RG makes an angle 45 degrees with the vertical. Similarly, RH. What is RH? RH is a force which is perpendicular to CE. Given that CE makes an angle 15 degrees with the horizontal. That means the RH makes the same 15 degrees angle with the vertical. Hence, this is the various forces acting at a point, or you can say the free body diagram of the cylinder. Problem number 2.9, that is, two rollers of weight P and Q are supported by an inclined plane and vertical walls as shown in figure. Draw the free body diagram of both the rollers taken separately. So in this problem, there are two rollers P and Q. Clearly we can see in the diagram P and Q are supported by some fixed support. Let us give some names here: D, E, F. So the rollers P and Q are supported by a fixed walls of D, E, F, inclined fixed walls of D, E, F. Our interest is to draw the free body diagram of roller P and Q separately. Let us discuss roller by roller. First, let us consider roller P. The weight of roller P, that is weight P, is acts downwards. Clearly it is already indicated here. In addition to this, this roller P is supported by the fixed wall at A and B, and also it is supported by another roller Q here. So at all these places reaction forces will develop. First consider at point A. What is the reaction force? Since it is the fixed support, the reaction force will be the perpendicular to fixed support, that is DE, and it is at point A and it is towards the roller P. This is the reaction at A or A. Similarly, the roller is supported at B. Hence, the reaction developed at point B is perpendicular to the fixed surface EF, and it is at B, and it is also towards the roller P. So this is reaction force at B. You can also look at the roller Q. The roller Q is supported by fixed support EF at point C. Hence, a reaction force develops at C which is perpendicular to EF and at point C, and it is towards the roller Q. Here the reaction force is RC. In addition to this, the roller P is supported by Q and Q is supported by P. So there must be reaction forces on each roller by the other roller. What is the direction of those reactions? Just by extending the same concept of these fixed support reactions, here also the reaction force will be perpendicular to the supporting surface. What is the supporting surface here? So to draw the perpendiculars, let us draw a tangent to this. Perpendicular to this tangent, along the perpendicular to this tangent, the reaction force will develop. That means the reaction force on P is perpendicular to this tangent and it is towards the roller P. Let this reaction is R. The same reaction will develop on roller Q perpendicular to this tangent and it is towards Q. The same reaction. So these are the various forces that are acting on the rollers P and Q. Let us transfer all these forces onto separate XY plane. First, let us consider the various forces are acting on roller P. So this I am considering for roller P. This is my P. The first force is self-weight P, of course, always acts downwards and the magnitude is P. The next one is reaction RA, which is perpendicular to DE towards the roller P. That means just I am transferring this onto my XY plane and this magnitude is let RA. What is the other force acting on the roller P? RB. Just transfer this RB, which is perpendicular to EF, and just I am transferring. In addition to that, there is a reaction force from roller Q onto roller P. That also I need to represent here. This one. This force I am transferring to this. What is the magnitude? Let us say R. So this is the free body diagram of roller P. We need to indicate the angles also, very important. P is vertical, of course, along y-axis. Now let us take RA. We know that RA is perpendicular to DE and that DE makes an angle 15 degrees with the vertical. Hence, RA makes the same 15 degrees angle with the horizontal. That means this angle becomes 15 degrees. Let us extend the same concept for the reactions RB and RC. RB is perpendicular to EF and EF makes an angle 15 degrees with the horizontal, hence RB makes the same angle 15 degrees with the vertical. Now R force. This R force is parallel to the surface. This R force is parallel to the surface, parallel to EF. And EF makes an angle 15 degrees with the horizontal, hence R makes an angle 15 degrees with the horizontal. So this is the total free body diagram of roller P. Let us extend the same concept to roller Q. This is my XY axis. I am considering my XY axis. First I am drawing the self-weight Q. Next RC. RC is the reaction force at C which is perpendicular to EF. RC. This EF makes an angle 15 degrees with the horizontal, hence RC makes the same 15 degrees angle with the vertical. So this is RC. Okay. Sitting on Q, that is R, that R I am transferring onto the XY plane. What is the angle? This is the same line. So this angle makes 15 degrees with the horizontal. Hence this angle is 15 degrees and this angle. RC makes an angle 15 degrees with the vertical like this. And R makes an angle 15 degrees with the vertical like this. Hence this is the free body diagram of roller Problem number 2.10. Determine the components of 1000 newtons force along axis A and B as shown in the figure. Compare these components with the rectangular X and Y components. The formula or concept that is required to solve the problem is rectangular components. Any force F can be resolved into two different forces if the angle between those two forces is 90 degrees, then it is called rectangular components of forces. If the angle between those two forces is not 90 degrees, then it is called general components of forces. First consider this force. Let this force F makes an angle theta with the horizontal. You can resolve this force into two components. One force is along x-axis, another force is along y-axis. The angle between this x and y-axis is 90 degrees, hence I can say it is rectangular components. What is the component of the force along x-axis? Remember, here the force F makes an angle theta with the x-axis, hence the x component is cos component, and that magnitude is F cos theta. Fx. And similarly, the component of the force along y-axis is Fy is equal to F sin theta. And what about the directions? A thumb rule I am saying for directions. If force is divergent, these two forces are also divergent. If this force is convergent, these two forces are also convergent. What do you mean by that? For example, if the same force I want to resolve here, this is my x-axis and this is my y-axis, and this makes an angle theta with the horizontal. Clearly you can see, as far as this point is concerned, this force is convergent. Hence, the two forces, one force act along x-axis, this is Fx, direction is this one, Fy direction is this one. All three forces must be convergent. But here, all three forces must be divergent. That is the thumb rule you can remember. Let us consider this second one. The same force F makes an angle theta with the y-axis. We would like to resolve this force along y-axis and x-axis. Since angle between x and y-axis is 90 degrees, we can consider these are the rectangular components. What is the directions of this force? Fx, this is divergent, and Fy, this is also divergent. All three are divergent. And what is the magnitude of the forces? Fy. Since this F makes an angle theta with the y-axis, y component becomes cos because it is adjacent, and the other component becomes sine. This is a thumb rule you can find. The first thumb rule, all forces must be either convergent or divergent. The second thumb rule is the adjacent side component becomes cos. Since this force makes theta with the y-axis, so y component becomes F cos theta. Similarly, let us consider this force F. This makes an angle theta with the y-axis. I would like to resolve this force into along x and y axis. Angle between those two is 90 degrees. Since here also F is divergent, those two forces components must also be divergent, Fx and Fy. Now here this force makes an angle theta with the y axis, hence the y component becomes cos theta, horizontal component becomes sin theta. Same force, for example, I want to resolve here. Can you able to understand now? The same force I want to resolve here. As far as this point is concerned, this force is convergent and this makes an angle theta with the vertical. So the two components of the forces, one force is acting like this, another force will act like this, and this is of course Fx is equal to F sin theta, and this is Fy is equal to F cos theta. Okay. Now let us take the last case. There is a force F which makes an angle theta with the x-axis. I want to resolve this force F. So as far as this point is concerned, this is divergent. So my force components are also divergent, and this also makes an angle theta with the x-axis. Hence x component becomes cos and y component becomes sine. So Fy becomes F sin theta and Fx is equal to F cos theta. So these are the rectangular components. Similarly, we have general components. What do you mean by general component? A force F can be resolved into two components of the forces, and the angle between those two components of forces is not equals to 90 degrees, then such types of components are known as general components. For example, if you consider this force F, this force F I want to resolve along A and B. The angle between A and B is not 90. Let the angle between F and A is alpha, angle between F and B is beta, and the angle between A and B is theta, which is not equals to 90. Okay, then what is the component of the force? The same concept you can extend, either convergent divergent concept you can extend. Since as far as this point is concerned, F is divergent, Fa is divergent, Fb is also divergent along the axis Fa and Fb. And what is the magnitude of this force Fa? There is a formula. Fa is equal to F, I am talking about Fa. Fa is equal to F by sine theta into sine beta. F by sine theta into sine beta. Similarly, Fb is equal to F by sine theta into sine alpha. These components are known as general components. With this concept, let us go to our problem. This is our problem. Now in this problem, the 1000 newtons force I want to resolve along A and B axis, similarly along X and Y axis. Clearly we can observe that these X and Y axis are rectangular components, and A and B are not rectangular components because the angle between A and B is not 90. First I am going with the general components. That means I am resolving this 1000 newtons force along A axis and along B axis. Since these are the general components, I am using this formula. The force along A, Fa, is equal to F by sine theta, that is sine 80, and how much is this angle? Obviously this becomes 50, hence it is sine 50. So Fa is equal to 1000 by sine 80 into sine 50, which gives the value of 377.86 Newton. So this is the direction of Fa. And what is the direction? Direction of FB is of course divergent, so it must come like this, and we would like to calculate the magnitude. According to the formula, FB is equal to 1000 divided by sine 80 into sine 30. Upon simplifying, you will get FB is equal to 507.71 newtons, and this is the direction of F. Now take rectangular components x and y. Now this force 1000 newtons makes 30 degrees with the x-axis. Hence x component becomes cos, y component becomes sine. Let us see, Fx is equal to 1000 into cos 30, and the direction is along this one only, Fx 866.02, and along this one, divergent. What about the y component? Fy is equal to 1000 into sine 30, and that value is 500 newtons, and this direction is along y, and it is also divergent. Problem number 2.11. Resolve the force into rectangular components with the given coordinates as shown in the figure. So in this problem, first we will solve sub-problem A. Here the force F makes an angle alpha with the x and y axis. Remember, x and y axis always need not be horizontal and vertical. It may be inclined also, but only the thing we need to remember is the angle between x and y must be 90 degrees so that it becomes rectangular components. So here x-axis is like this, y-axis is like this, given that angle between x and y-axis is 90 degrees. Now the force F makes an angle alpha with the y-axis, and clearly we can see it is the divergent as far as this point is concerned. Hence, the component of the forces are, one is Fy, divergent from point y, and another one is Fx, divergent from this point. What is the magnitude of Fy? Since the force F makes an angle alpha with the y, so y becomes cos component, so Fy becomes F cos alpha, and obviously Fx becomes minus F sin alpha. Why I am saying it is minus F? The positive x-axis is given in the upward direction, but my component is acting in the downward direction. Hence, the magnitude may consider as minus F sin alpha. Let us take sub-problem B. Here, the force F makes an angle alpha with the y-axis. Absolutely same problem compared to the previous problem. But the difference is, here x is given as the positive upwards, but now positive x-axis is given as the downward direction. Hence, the component of the forces are Fx and Fy. Now what are the magnitude here? The force F makes an angle alpha with the y-axis. Hence, Fy is equal to F cos alpha and Fx is equal to F sin alpha. Clearly here I mentioned minus, here I mentioned plus. What is the reason here? Reason here is x-axis is positive in this direction, but my force is acting in the downward direction. Hence it is negative. But here the x-axis is positive, my force is also acting in the downwards, so it is positive. Let us take the subsection C. Here this is x-axis and this is y-axis, but force is acting here. I want to resolve this force along x and y-axis. The angle made by the force F with the y-axis is given as alpha. So what I will do is, I will transfer this x-axis onto this. Now since this angle is alpha, then I want to convert this into this angle, that is 180 minus alpha. What is my y-axis now? This is my y-axis. So the component of the force Fy is convergent, because F is convergent, the component of the force Fy is convergent. So Fy is equal to F into cos 180 minus alpha, and this is minus F cos alpha. Now let us take this x-axis. This x-axis I am passing to this. Just drawing a line parallel to this. So this is my y-axis now, this is my x-axis. Since along y-axis the angle is 180 minus alpha, so this is minus F cos alpha. Obviously, what is the component of the force along x-axis? This is also convergent towards this point, and that value is F into sine 180 minus alpha, that is equal to F sine alpha. Let us go to the last subsection, D. This is the force F. That force F makes an angle beta with some particular line. That particular line makes an angle alpha with the x-axis. I want to resolve this force along x-axis and y-axis. So what I will do is, I will first construct my x and y axis at this point. Just I will draw a parallel line to this y-axis, I will draw a parallel line to this x-axis. Now as far as this point is concerned, the force F is divergent. So the components of the force must be divergents. One is along this one and another one is along this one. But what about the angles? So clearly you can see this line makes an angle alpha with the x-axis. Then what about the angle made by the force F with the x-axis? It must be alpha minus beta. Since the force F makes an angle alpha minus beta with the x-axis, then I can resolve the force along x-axis Fx now, which makes the magnitude as F into cos alpha minus beta. And similarly Fy, which is also divergent, and that value is given by F into sine alpha minus beta. Problem number 2.12. In level flight, the chord AB of an airplane wing makes an angle alpha is equal to 5 degrees with horizontal as shown in the figure. The resultant wind pressure on the wing for such conditions is defined by its lift and drag components. L is equal to 6675 newtons and D is equal to 819 newtons, which are vertical and horizontal respectively as shown. Resolve this force into rectangular components x and y coinciding with the chord AB and its normal respectively. Now, in this problem, there is a flight which is not horizontal. This makes an angle alpha is equal to 5 degrees with the horizontal. Now the wind force is acting on the flight along vertical and horizontal, namely lift and drag force, with some magnitude 6675 and 819 newtons. Now our aim is to identify what is the net force acting along x-axis and what is the net force acting along y-axis. So what we will do is, we will resolve this L force along x and y-axis, and we will resolve this drag force along y and x-axis. First let us consider the lift force by resolving the lift force along x and y axis. Let us redraw that x and y axis. Let us transfer that x and y axis onto a separate plane. So this is my y axis. I am transferring to this on a separate page. and this is my y-axis. This is x-axis. This is my x-axis. I want to find the net force along x and y-axis. So first I am considering L force. What is L force? Given that L force is vertical and this makes an angle alpha with the y-axis, which makes an angle 5 degrees with the y-axis. Now let us resolve this force L is equal to 6675 along y and x-axis. From the concept of this convergent and divergent, the force F is divergent, hence the force along y-axis and x-axis and the direction of these forces are like this. This is the direction of force Lx and this is the direction of force Ly. And what is the magnitude of this force? Since the force F makes an angle 5 degrees with the y-axis, Ly becomes cos component, that is Ly is equal to 6675 into cos 5, which gives the value of 6650, and the other component, that is Lx, becomes sine force, that is 6675 into sine 5, which is equal to 581.8 newtons. These are the components of the forces along x and y axis as far as L force is concerned. Similarly, we will resolve that D force along x and y axis. Once again, I am transferring the x and y onto some separate space. This is my y axis and this is my x axis. I am transferring, this is my x axis. Now I would like to resolve D force, hence I am drawing the D force now. The D force is given that D force is horizontal and also given that makes an angle 5 degrees with the x axis. So we can resolve this D force along x and y axis. So what is the direction of this component of force along x axis? Fx. This is the direction of force along x axis, divergent, that is dx. And similarly dy, the component of force along y axis, dy, it is also divergent, so it is acts like this. And what about the magnitude? Since the D force makes an angle of 5 degrees with the x axis, dx becomes cos component, that is 890 into cos 5, and dy becomes a sine, that is equal to 77.6 newtons. So these two forces are the component of D forces along x and y axis. Already we have resolved that L force along x direction and y direction, Lx and Ly, we have some values. Let us overlap these forces onto the x and y axis. My Lx is like this. I am just overlapping this force here. And my Ly is like this. And my Ly is like this. And the magnitude of Lx and Ly also known to us. Now, what is the net force acting along x-axis? dx force is acting towards right side. The Lx force is acting along left side, but both the forces acting along x-axis only. Hence, the net force along x-axis is equal to dx minus Lx. That means 886.61 minus 581.8, which gives 304.8 newtons. Net force acting along x-axis is equal to 304.8 newtons. Similarly, let us find the net force acting along y-axis. dy is acting upwards, Ly is acting upwards. Hence, the net force along y-axis is equal to dy plus Ly, and this is 77.6 plus 6650, which gives the value of 6727.6 newtons. What is the final answers? If this is my x-axis, and if this is my y-axis, this is x-axis and this is my y-axis, and the net force along x-axis is Fx. Finally, I can consider x, which is equal to 304.8, and the force along y is equal to 6727.6. These are the final answers for this problem. Problem number 2.13. A small block of weight Q is equal to 44.5 newtons is placed on an inclined plane which makes an angle of 30 degrees with the horizontal. Resolve the gravity force Q into two rectangular components Qt, Qn acting parallel and normal respectively to the inclined plane. That means there is an inclined plane of 30 degrees angle. A block of weight Q is placed on this inclined plane and the weight Q is 44.5 newtons. Our aim is to resolve this force into two components. One is along this line and perpendicular to this line. So in this problem, the weight Q is acting in the downward direction. Let us draw our x and y axis. So one axis is parallel to this inclined plane, so I am transferring that onto a separate place, and perpendicular to that plane, this one, this I am transferring to some space. So this I will consider as my x-axis, this I will consider as my y-axis. Now our interest is to resolve this Q along this x and y. So let us transfer this Q force onto this xy plane. And given that Q is equal to 44.5 newtons. Now the most important point of this problem is we need to find the angle between the Q and either x-axis and y-axis. Since this inclined plane makes an angle 30 degrees with the horizontal, Q makes an angle 30 degrees with the perpendicular to that inclined plane. Okay, so this angle will be 30 degrees. This angle will be 30 degrees. Once you know that this angle is 30 degrees, you can resolve into along y-axis and x-axis. By using that thumb rule, the component of the force Q along y-axis is like this. The component of the force Q along x-axis is like this. Given that component of the force along y-axis is Qn, the component of the force along x-axis is Qt. Since the Q makes an angle 30 degrees with the Qn, Qn becomes cos component, Qt becomes sine component. Hence Qn is equal to Q into cos 30, and this value is 44.5 into cos 30, that is 38.54 newtons. And the other component, that is Q2, becomes sine component. So this is Q2 is equal to Q into sine 30, 44.5 into sine 30, which gives the value of 22.25 newtons. So the final one becomes, so this we can transfer back to the inclined plane. So this becomes Qn and this becomes Qt, and the answers are, this is 22.25 newtons and this is Qt 38.54 newtons. These are the components of Q, parallel and perpendicular to the inclined. Number 2.14. For the particular position shown in the figure, the connecting rod BA of an engine exerts a force P is equal to 222.5 newtons on the crank pin at A. Resolve this force into two rectangular components PH and PV acting horizontally and vertically respectively at A. This is the force P acting like this on crank pin A. This we would like to resolve into two rectangular components horizontally and vertically at point A. That means I want to resolve this force P along these two axes. In order to resolve this force, I must know the angle made by the force P with either x-axis or y-axis. For that, I will construct a small right angle here, OAC. OAC is right angle. In that, angle O is given as 45 degrees. Let this angle is alpha. Let this angle is alpha. Now, from the right angle triangle OAC, sine 45 is equal to opposite side, that is AC divided by 254 mm. Hence I can calculate AC value as 179.6 mm. This AC value I got as 179.6 mm. Now I will consider the triangle ABC, from which I can calculate the value of alpha. How I can calculate that alpha? So from triangle ABC, sine alpha is equal to AC by the hypotenuse, that is 508 mm. So sine alpha is equal to AC value, just now we calculated 179.6 divided by this value as given as connecting rod length AB is given as 508. Hence I can calculate alpha 20.7. Now let us go to our actual problem. What I will do is, I will transfer this x and y onto separate space so that I can easily understand the resolution of the forces. So just I am transferring this. This is my point A. This I will consider as my x-axis. This I will consider as my y-axis. Now, I am transferring the force P. This is my force P. I am transferring that force P onto my xy axis. Now, what is the angle? Now, this connecting rod, that is this force P, makes an angle alpha with the horizontal. Hence, this force P, that force, makes an angle alpha with the horizontal like this. Because if this angle is alpha, this angle must also be equals to alpha, because opposite sides angles are same. And given that this alpha, or we calculated this alpha value as 20.7 degrees. And now this P force, as far as A point is concerned, this P force is convergent. So the component of the forces along x and y must be convergent. So the component of the force along x-axis, that is PH, is along like this towards point A, and the component of the force P along y-axis, that is PV, is towards downward, that is towards point A. These two are the directions of these two forces PH and PV. What about the magnitude? The force P makes an angle alpha with the PH component of the force, hence PH component becomes cos component. So pH is equal to P into cos alpha. And the magnitude is 222.5 into cos 20.7, which is 2081.4. Similarly, the component of the force along y-axis is Py, and that Pv is equal to P into sine alpha, that is 3225 into sine 20.7, which is 786.5 newtons. These two are the answers for this problem. Let us transfer these two forces onto original xy axis. So if we transfer that, then I will get here, this is the component of pH and this is the component of PV. So this is pH, this is PV, and what about the original force? This is my original force, that is P. Problem number 2.15. Resolve the force P, that is 2225 newtons, in figure into two rectangular components PR, PT, acting along the radius AO and perpendicular thereto respectively. So in this problem, a force P, where is force P? This is the force P. A big force I am drawing here. This is the force P. This is force P is acting at point A. Now our aim is to resolve this force into two components, and those two components are like this. One is along AO and another one is perpendicular to AO. Let us assume that this is my x-axis and this is my y-axis. We need to resolve this force P along this x-axis and y-axis. For that, I should know the angle made by this force P with either x-axis or y-axis. To know that, let this angle is alpha. Let this angle made by the force P with the horizontal is alpha. Given that the angle made by this AO with the horizontal is 45 degrees. Now let us draw a vertical line passing through A, and I will put a name here, C. Consider the right angle triangle OAC. Then sine 45 is equal to opposite side AC by this OA, that is 254 mm, that value is given. Upon simplification, I will get AC value is 179.6 mm. I know this length AC is equal to 179.6 mm. Now I will consider the right angle triangle ABC. Sine alpha is equal to AC divided by AB. AB value is given as 508. Sine alpha is equal to 179.6 divided by 508, which gives the value of alpha is 20.7 degrees. So alpha value is known, that is 20.7 degrees. Now let us go to our problem. Let us transfer the x and y axis onto a separate place so that I can easily analyze this problem. So this is my x-axis and this is my y-axis. Now where is force P? This force P also I am transferring onto this. Now in order to find the component of this force along x and y axis, I must know the angle made by this force P either with x-axis or y-axis. For that, you just construct a horizontal line here at A. Since you know that the angle made by the force P with the horizontal BC is alpha, hence this angle will also be equals to alpha, because opposite sides are same. Similarly, the angle made by AO with the horizontal is given as 45. Hence, the angle made by this line that is x-axis with this horizontal will also be equals to 45 because opposite sides are equal. Hence, what is the total angle made by the force P with our x-axis? Alpha plus 45. That is 65.7 degrees. Once you know that the force P makes an angle 65.7 degrees with the x-axis, so you can resolve this force along x and y axis. And remember, this is a convergent force, so the component of the force must also be convergent. The force along the component of the force along y axis is like this, towards downwards, towards this point. And so this value is Pt, given that this is Pt. Next, component of the force P along x-axis, and it should be convergent. It is like this, and this value is Pr. Now, what about the magnitude? From this diagram, the P force makes an angle 65.7 degrees with Pr. Hence, Pr component becomes cos component and Pt component becomes sine component. Hence, Pr is equal to P into cos 65.7, and P value is given as 3225 into cos 65.7, which gives 915.6 newtons. Similarly, Pt is equal to the sine component, which is P into sine 65.7, that is 222.5 into sine 65.7, which is 2027.9 newtons. Now let us transfer these forces onto original diagram. So transfer that. Now this is the value of, this is the actual force P. Now PR and PT will act like this. So this is the PT and this is PR, and the values are here. Problem number 2.16. If the resultant of two forces exerted on the body at A, as shown in the figure, is to be vertical, determine the value of beta for which the magnitude of P is maximum and the corresponding magnitude of P. So, in this problem, there is a body A and two forces are acting on the body at A. 1000 newtons force and P is the force which is unknown. The angle made by 1000 newtons force with the horizontal is given as 15 degrees, and the angle made by the force P with the vertical is beta. Now, given that the resultant force is vertical, the resultant force R, let R is vertical, which is also an unknown. Now, our aim is to find the value of beta so that P should be maximum. What is the value of beta so that P is maximum? That means the value of beta so that R should be vertical and P should be maximum. Both the conditions must be satisfied. How can we solve this? Now, in this problem, this 1000 newtons force makes an angle 15 degrees with the horizontal. Hence, it makes 75 degrees with the vertical, so that these two becomes 90 degrees. Angle between horizontal and vertical becomes 90 degrees. Now, the angle between these two forces, 1000 newtons and P, is 75 plus beta. the angle between R and 1000 newtons, we know that the angle between R and 1000 newtons is 75 degrees. So you can write the equation as sine 75 is equal to P by R into sine 75 plus beta. You can rearrange this equation in such a way that P is equal to R into sine 75 by sine 75 plus beta. Our aim is to see that P should be maximum. What is the value of beta? So that P should be maximum. So for P should be maximum, so the total differentiation of R into sine 75 by sine 75 plus beta should be 0, or since R75 is constant, d by d beta of 1 by sine 75 plus beta is equal to 0. That means d by d beta of 1 by sine 75 plus beta should be equal to 0. What is d by d beta of sine 1 by sine 75 plus beta? It is minus cosecant 75 plus beta into cot 75 plus beta into beta is equal to 0. This you can rearrange. Minus cosecant I can consider as minus 1 by sine 75 plus beta into cot 75 plus beta I can written as cos 75 divided by sine 75 plus beta. So in the numerator I have minus cos 75 plus beta, and in the denominator I have sine square 75 plus beta. So this is equals to, the numerator must be equal to 0. That means cos 75 plus beta must be equal to 0. When this cos 75 plus beta must be 0, then or you can simplify this as cos 75 plus beta is equal to cos 90, or 75 plus beta is equal to 90 and beta is equal to 15 degrees. That means if beta is equal to 15 degrees, P value will be maximum. Let us see what is that value. So here that P value we just calculated it as 15 degrees. Now the angle between R and P is beta, and that value is sine 15. So what equation I can write now? Sine 15 is equal to 1000 by R into sine 75 plus 15, which is R is equal to, from that I can calculate the resultant force. R is equal to 3863.7 newtons. Similarly, I know the angle between R and 1000 newtons as 75 degrees. So what equation I can write now? Sine 75 is equal to P by R into sine 75 plus beta. We know that beta is equal to 15, and R value we just know we calculated. You can substitute here. Hence I can calculate P value as 3863.7 into sine 75. Hence the maximum value of the force P is equal to 3732.05, problem number 2.17. Three forces are applied to a body as shown in the figure. The directions of the 200 newtons may vary, but the angle between these forces is always 30 degrees. Determine the range of value of alpha for which the magnitude of the resultant of the forces applied to the body is less than 650 newtons. There are three forces are acting on the body. One force is 100 newtons here, 100 newtons here, and is 600 newtons. This 600 newtons makes an angle 45 degrees, which is always fixed. This 100 newtons angle between these 200 newtons 30 degrees is also fixed. Now, this alpha may vary. It may 0 or 20 or 30, whatever. This alpha value may vary. Now, I want to find the value of alpha for which the resultant force is always less than 650 newtons. In this problem, the resultant of, first we will calculate the resultant of these two 100 newtons force, because the angle between these two 100 newtons force is 30 degrees. So I can find the resultant of these two forces, and also I can find the angle made by the resultant with either of these 100 newtons. So how to find the resultant of these 200 newtons forces? R is equal to square root of, this is the formula. If P comma Q are the two forces, this is the formula. Just now we have seen. Now by substituting this, I will get square root under 100 square plus 100 square plus 2 into 100 into 100 into cos 30. So I can find the resultant of these 200 newtons force is 139.2 newtons. And the angle between the resultant force and either of the 100 newtons is given by sine beta is equal to Q by R into sine alpha. This is the formula. According to that, sine beta is equal to 100 by 139.2 into sine 30. Then I will get beta is equal to 15 degrees. That means I can replace these 200 newtons force with a single force of 132.2 newtons, which makes an angle of 15 degrees with this one. That means this is the diagram now. There are only two forces acting on the body now. One is 600 newtons, another one is 139.2 newtons. That 600 newtons makes an angle 45 degrees. This 193.2 newtons force makes an angle of alpha plus 15 degrees with the horizontal. Then what is then I can find the resultant of these two forces. Given that the resultant of the force must be less than 650 newtons. That information is given. So I can find the resultant of 600 newtons and 193.2 newtons according to this equation. Square root under 600 square plus 193.2 square plus 2 into 600 into 193.2 into cos of these two angle between these two forces. This is 45 plus alpha plus 15, that is 60 plus alpha. So I can simplify that. Given that the resultant of the force must be less than 650, so this R value must be less than 650. That means square root under 600 square plus 193.2 square plus 2 into 600 into 193.2 into cos 60 plus alpha must be less than 650. Can simplify this. For simplifying, then I will get an equation like this: 397356.24 plus 231840 cos 60 plus alpha should be less than 422,500. This is got by squaring on both sides. So further I can simplify this. That is cos 60 plus alpha must be less than 0.108. So 60 plus alpha should be less than 83.77, because cos 83.77 is equal to 0.108. So I can substitute. Hence the alpha value should be 23. Alpha should be always less than 23.77 degrees. There is another possibility for 0.108. What is the other possibility? So cos of 276.23 is also equals to 0.108. I will take that answer. So 60 plus alpha should be less than 276.23, and then alpha should be 216. So the range of angle will be 23.77 and 216. Hence the range of angle must be alpha is less than 23.77 and it should be less than 216. Problem number 2.18. Three forces are applied to a body as shown in the figure. The directions of the 200 newtons may vary, but the angle between these forces is always 30 degrees. Determine the range of values of alpha for which the resultant of the forces acting at A is directed horizontally to the left if P is equal to 250 newtons. That means there is a body and three forces are acting on the body at A. One force is 250 newtons and the angle made by the 250 newtons with the horizontal is 45 degrees. And there are two other forces, 100 newtons and 100 newtons, acting on the body. Angle between those 200 newtons is 30 degrees. But this alpha value may change. Now our aim is to find the value of alpha in such a way that the resultant force is horizontal and it is towards left side. So in this problem, first let us try to find the resultant of these 200 newtons force. The angle between these 200 newtons force is given as 30 degrees. So I can find the resultant by using this formula just now we discussed, and after substituting that, R1 is equal to square root under 100 square plus 100 square plus 2 into 100 into 100 into cos 30. I will get 193.2 newtons. And angle made by the resultant with either of the 100 newtons can be calculated by using the equation sine beta is equal to Q by R into sine alpha. So sine beta is equal to 100 by 193.2 into sine 30, which gives the value of 15 degrees. That means I can replace these 200 newtons force with a single force of magnitude R1 is equal to 193.2 and makes an angle 15 degrees with this 100 newtons. So this is my new diagram now. There are only two forces. One is 250 newtons, another one is 193.2 newtons. This 250 newtons makes an angle 45 degrees with the horizontal, and this 193.2 newtons makes an angle of 15 plus alpha with the horizontal. Now my aim is to see that this resultant force, the resultant of these two forces must be horizontal and it is towards left side. For that, I will use this formula. Let the angle between R and P is 45 degrees, that is given. The angle between R and P is 45, that is given. So I can substitute in the formula that sine 45 is equal to 193.2 by R into angle between these two forces, that is sine 60 plus alpha. So I will get one equation in terms of R and alpha. R, I can say R is equal to 193.2 by sine 45 into sine 60 plus alpha. I can rearrange this equation. And then upon solving this, I will get R is equal to 273.23 into sine 60 plus alpha. Let this equation is 1. Now I will take the other equation. I know that the angle between R and this 193.2 is sine 15 plus alpha. That I know. So I can say that sine 15 plus alpha is equal to P by R, that is 250 by R into sine 60 plus alpha. So this I can simplify and I can write that R is equal to 250 by sine 15 plus alpha into sine 60 plus alpha. This is my equation 2. Equation 1, I have one equation R is equal to so and so, and for equation 2, I have another equation R is equal to so and so. By using the equations 1 and 2, I can write the equation as 273.23 into sine 60 plus alpha is equal to 250 into sine 15 plus alpha into sine 60 plus alpha. So sine 60 plus alpha gets cancelled. Then I can get sine 15 plus alpha is equal to 250 by 273.23. That means sine 15 plus alpha is equal to 0.915. That means, so this 0.915 means sine of 66.205 is 0.915. So after simplification I will get 15 plus alpha is equal to 66.205, or alpha is equal to 51.205 is the final answer. My dear friends and students, if you want the solution for any of the subject in the field of machine design, namely strength of materials, theory of machines, machine design, engineering mechanics, finite element method, mechanical vibrations, please give the reference in the comment section so that I will solve the problem, prepare a video and upload in my channel. Please subscribe and share my video